Well, hey guys, welcome back to the channel and welcome back to the amazing 1/5 scale F-16 from BVM. We're making some amazing progress on this aircraft. Last video, we got the engine installed. We're moving forward now and getting into the finer details to wrap this aircraft up. So let's dive back in to this plane. All right, so we left off the last video just kind of finishing up the board and getting some of our equipment mounted and finalized there. Last thing we did on the previous video was get our airline hooked up to our chute mechanism. So now that's all done. We've got our supply figured out. So the air system, with the exception of mounting the compressor, is complete. So that is great. We're making some good progress here. The only thing left to mount on the board is, I believe, our V-speak and maybe a receiver. And that's it. So the next thing we're going to start off with here is we are going to program our central box, Cortex combination. So it's more about the Cortex than the central box, but let's get into some of the finer details in this video. So first thing we have to do with the Cortex is we've got to plug in our primary receiver into port A to program. Then we're going to have another port coming out of channel 6 into R1. Now you may not agree with how we set these planes up, but that's okay. So we have, with this particular customer, we use a primary receiver and a clone. So with the primary receiver, we are using channels E1 and E2. So E1 is our primary receiver output. That's going to go into our Cortex, which goes into R1 on the central box. E2, we change that to be an input, a backup input. Our clone goes on its E1 and E2 channels. So E1 is going to be an output coming to this E2, and then the other output on the clone receiver is going to bypass the Cortex and go into R2. Now the reason for all that is it's a bit of a rock solid scenario here. So if the primary receiver fails, the clone plugged into R2 works without the Cortex, just works. It's going to say you lost signal and stuff, but you still have control. If the Cortex is to fail, the primary receiver is no longer, I don't think, going to be able to send the signal through the Cortex. Of course, it depends on how it fails. So we've got our clone plugged into here, but we also have our clone plugged into R2. So barring a huge issue with the central box, that is providing our backup for our receiver system. So I'm going to do a short little lead up here going between the Cortex to R1, and then we want a secondary power supply, so we'll get that done up. When I get those done up, we'll come back and do some programming. So I'll show you guys our channel layout here. This is for our first channels that actually are in existence on the central box. So what is really important here is the throttle channel, which is number 3, and also our second throttle channel, which is number 14. You can see it right there to the right of the black square. So we've got a gyro sense channel that's on channel 16. Now generally in this type of setup, we don't just want to have this one cable providing power to the Cortex and the receiver. It's always nice to have a backup power supply. So usually if we're not struggling for channels, maybe we'll put gyro sense, which is our gyro gain channel. So if you look there, gyro sense is channel 16, and that basically adjusts the gain of our gyro, but there's not a physical cable on this channel. So if we had a gyro sense set up on, let's say 13, we would run the blue and red wires or positive negative wires to supply some more power to the Cortex and receiver system. But we don't have that luxury in this setup because our second our gyro sense channel is channel 16, which doesn't exist on the central box. So what we're going to do is we're going to run a cable into port 5. This is just the positive negative that comes down and goes into our throttle channel, our actual throttle channel, which is port number 3. So how are we going to run the turbine then? What we're going to do is we're going to run the Swewin Beast with our V-speak. So this is going to run on the EX bus system. So we're going to have our telemetry cable going into here, or our blue cable going into the telemetry port. This cable is going to go on into our jetty system, and our actual throttle cable, which is this one here, we're not going to use that, so this can get bundled up and put aside. So that is how we're going to run this system. It also saves a channel here and opens up this channel to be able to supply power to the Cortex. Now we could just add a Y as well, that's an option too, so keep that in mind. If you're running into this situation, you can also add a Y cable and power some additional power from there. So let's do some Cortex programming here. So we've got our primary receiver going into port A on the Cortex, the port 6 going to our central box. We're ready to program this. So step number 1, we've got power put to our central box. When we pull this plug, it's going to power up the system. So we're going to power this up as a first step. And we take our programming plug and we put it in the programming port. So you'll see that flash blue quickly. And now what should happen is this should change to a single blue blink. There we go, we got a single blue blink. Now if you're using dual path, 2 receivers, you're using port A and B, you want that to be 2 slow blinks. But in this case, 1 slow blink is what we're looking for. So now we're going to power off our system. Now this is an important step. We take this primary receiver, we move it to port B. That is very, very important. So now when we power this on, it should go through its boot sequence. Mind you, we've got the bind plug in there, so we just got double bumps. No surfaces are hooked up, so there's nothing to give us our motion that it's happening. So we're right aileron, left aileron, forward elevator, back elevator, right rudder, left rudder, and gyro off. There we go. Cortex is all programmed, so we will pull out our bind plug, turn this off. Now let's confirm that it works. So we're pulling out our power plug, nothing in the programming port. Remember, no surfaces are hooked up. And we're good to go. So now if we turn gyro off, turns red, on is amber. So that is how you program the Cortex for this scenario. It's very important to do that pin switch or output switch. If you don't do that properly, it won't work. Okay, so we're just setting up the V-Speak and making sure that everything works before we kind of finalize this. So I've done a couple things here. Number 1, we have turned on the taxi tank feature. So what that means is when you start up the aircraft, it's assuming you're pulling from the taxi tank. So you're going to see your fuel number drop down, and then when you want to reset it, you go full throttle, back down, and then it's supposed to reset to the fuel number. So that is a feature that's kind of cool, but also it's kind of important on a plane like this. So, I mean, it does have 6.8 liters of fuel, but 6.8 liters with a Beast is not a ton of fuel, but it's enough. But generally you want to be using a taxi tank with a plane like this. So the theory is when you unplug your taxi tank from the aircraft, you throttle up, throttle down. The engine, it needs to be quick enough that the engine doesn't even respond. And it's going to reset your fuel numbers. So cool little feature. And then the other thing we're doing is because we're running this as an EX bus, we're going to go into our throttle setting, go down to servo, and our throttle is, this defaults to number 1, but our throttle is on channel 3. So we want to make sure we switch that to channel 3, which we have done. All right, so we wanted to make the tail section more snake-like. So it's hard to tell the prep that I did there, but with the shine and the lights, you can probably see it. So this entire back and lower section is going to be black. And then what we did was continue the black right here rather than just having like a termination point, continued the black rearward coming to a point. So kind of kept the same spacing that you see on the rest of the tail section, that kind of 1 inch ish 3/4 inch type spacing, but just continued it towards the back. So the black's going to help to break everything up. So we'll let that cure a little bit. We're going to peel off our tape, and we'll see what it looks like before we put clear on it. All right, and there's the tape pulled off, and that turned out, I think, really good. It's a nice nice lines on this versus just having it all be ugly gray. So it's pretty ugly right now with the original clear coat sanded. The new paint area is kind of textured, and anyways, once we get that all clear coated, it will look phenomenal. But I think that turned out beautiful. Okay, so we're ready to put our clear on our tail section here. Now, I found this great product at our local automotive place, and this is a 2K clear, but there's no burst package in the bottom. So generally with 2K clears, aerosols like this, you push the button on the bottom, it pokes the seal between the two, you mix it, and you've got like a certain time period, 24 hours or less, to use it before it solidifies. This is two separate things in here that mixes at the nozzle. When you're done with this, you flip it upside down, spray it for 5 seconds, and you can reuse this. So I thought that was super cool to try out. I mean, the 2K product itself is pretty awesome, but this with a reusable container is magic. All right, so just kind of flipping through the manual here, and I get to one of the last pages in the manual, and it is the rear stabs and the vertical. So what we've done here is drilled along the receptacle that holds the movement actuator. So the point of doing this is to check and make sure that they have high-soled this properly, and they do cover this in the manual quite well. So if you drill these holes through there and you get resistance, you know that there's epoxy in those areas. So there was when I drilled these out. The other thing that I did was I soaked the wood that's in here in thin CA. So I just kept filling thin CA in there until it was completely full, just to make sure that the wood gets soaked. So that's one more step to just kind of reinforce this area a little bit more. So I've done this side. I'm going to do this side now with a 1/16 drill, but you just drill those out. And it's the same scenario on the vertical stab. You just need to be a little bit careful because everything's a little bit tighter in the vertical. All right, so I'm just getting these tabs done here that Kelly did up for us. Thank you, Kelly, for doing these guys. And these tabs go over the pins that come out to open and close the main hatch. So I just laid down some clear tape and used a little bit of high-sol to glue these in place. It's kind of a delicate procedure because if you put too much high-sol in there, it oozes out. So it's just a little bit of high-sol. Hopefully it holds very well. But we'll obviously paint them black, but we want to get this portion done first and get them glued in place. We've done that on both sides. All right, so it's the next day, guys, and our little tabbies here worked out great. I just pulled the tape off that we put down there, and these are nice and solid and mounted good. There's a little bit of movement in there. That movement is in the actual pin itself. So that worked out very nicely. I'm happy with that. So we'll take this off now. I'm gonna mask around that, and we're gonna paint these black, and they will absolutely disappear once we get that done. So we flipped our front tray over here. I've sanded down this and made a very aggressive pattern. We've sanded down our fasteners coming through for the gyro. So I'm gonna put high-sol all over this area. We're gonna put a piece of ply on the underside, and we're going to CA the perimeter of the ply to hold it in place. So this is basically a stiffener designed to stiffen up the gyro area is the whole point. So I'm kind of getting things cleaned up in the midsection there to get ready to install the compressor. So what I'm doing here is I'm just figuring out our wiring for our compressor. So what I do in this case is we're going to run the telemetry stuff from the SE6 module here. Of course, the power for the compressor is separate, but this uses the SE6 perfectly. So our first 5 ports there are all for the channels that are dedicated to them, and then number 6 is an open port. So this works out just perfect. And if we go to our sensor stuff here, we should see, there we go. We've got V-Speak, air system, on there. So everything's working properly with the compressor. So we've painted our little tabs. I put some clear coat on there, and when those are done, they will look, well, invisible. We also got our compressor mounted in the center section here, and I put a wire keeper. It's one that you can run a zip tie through right on that side. So what's going to happen is we are going to bundle all of that stuff through that wire keeper, and that's going to keep it away from the compressor, so we'll have some nice separation there. The compressor line is right there, so we're going to have a piece of Teflon line that loops around and plugs in to the compressor. With our SE6 here, with everything figured out now, I put a little bit of shoe goop on the SE6 to hold all the lines in place. I'm letting that cure before I touch the board, but this is the lead that's going to go back and plug into our compressor. So we probably could have made this work, but it's a lot easier to have a nice little extension there to make moving this board around much easier. All right, so working on the smoke pump setup here, and we've got everything kind of figured out. So this is our intake side with all the stuff going on. So the reason for all this intake stuff is we need to step up to the smoke tank system line, which we've done here with the brass fitting. So that goes from like 4 mil to 6 mil-ish. And then we've got a T in here, and you can see the Tygon line. Now what's this for? Well, this is our fill line. So our smoke feed, our intake, is gonna come from the tanks here. Now it doesn't really matter which direction this goes. You could also have the smoke tank feed here, and you could have the fill line there, but we're doing it a little bit different just because the way the plumbing's laid out. So when we are filling the system, this line here, this Tygon line, is going to have a little fuel dot in the back, and that's clipped in right here. So the smoke system is closed. You open up the Tygon line and you're filling smoke fluid. It can't go this way through the pump system. We've got the on-off valve on this side closing everything off. So on this side, it's going to go into the tank system. So that's the reason for this. This is basically adding in a filling system into a sort of closed system. All right, so we've got our nose cone attached here. That's just 2 Allen bolts, one on the top, one on the bottom. Used some Loctite on those, of course. And we've got these poly-ply plates to add on here. So we fasten those down with 5 screws. I also used a little bit of CA, just a couple dots, just to get it all lined up. You can see where it lines up, so your Velcro goes through there. Pretty sure the reason for the poly-ply plates is so you can put Velcro down and your batteries can be fastened to the Velcro, so that's the reason for that. So that's probably where our batteries are going to end up, is right here, and we'll have our plugins mounted to the front board right there, is my thoughts right now. So I'm just taking some small screws, and we're going to screw these plates down. So just working on some wiring here, making sure I understand how all the connections work with the black box and how it gets power and such. So plugged in the light or LEDs to the light channel. That of course powers up the black box, and we have lights working away. So look good. So these lenses here that I did, without these full epoxy lenses, you would just see a little hole of light coming out. Now the color lights up beautifully. And there is the red side. All right, so just kind of prepping our power situation here. So we're gonna plan on the batteries being up front. So quite simple on this aircraft. We're basically gonna have 2 fairly large 2-cell LiPo batteries, which are going to go roughly in this area, and then we're going to have a turbine pack on that side. So my plan is, for easy access, to use our XT60 battery connectors here. So these are available on my website, thelightersideofrc.com, and we've got them in gray, red, and black, and 2 different styles as well. So we're going to have these guys mounted up top, 2 like this, and then our turbine one is probably going to mount up like that. So it doesn't interfere with anything with taking the nose cone off, and also doesn't make it difficult to plug them in because they're on the outer line here. I could also fit them here and run them up and down. The problem is getting the plug in there is a little bit difficult, so easier if we run it there. So just to confirm our power setup and system on this aircraft, very straightforward. We don't need to run a ton of different batteries to power everything. This system works good. So we've got our two-cell LiPo batteries. These, this actual size yet, we're not sure, but these are 5000 60C Gen Ace batteries. We'll just assume that we're going to be using something this size in the front of the aircraft. Now, these batteries feed the central box. Now, what also comes off the central box is important. So we've got our smoke pump. The BVM smoke pump is designed to run off that central box or a power distribution type system, whether it's a power box or central box or spectrum type thing, power safe receiver. So that is what is powering essentially all the electronics on the aircraft. Now, turbine battery, this is just the battery we have in the shop here. This turbine battery is going to be feeding the turbine along with the V-speak compressor. So the turbine battery, the 3-cell LiPo battery, runs all of the turbine functions and the compressor. So it's a pretty simple layout on this aircraft. Thankfully, the central box handles all of the miscellaneous stuff. So that's what we're planning for when we run this electric system. So what does that mean? Well, it means that essentially these two connectors that we put on this side for our 2-cell LiPo batteries, they just run back and plug into the central box, which is easy. The turbine battery, which is on my side of the aircraft, that is going to run back to the turbine area, but it's also going to split off with another pair of leads that goes to the compressor. So quite straightforward, quite simple, and it makes for a nice, easy installation. All right, guys, and we made a boo-boo. So what I was doing here is I installed the cockpit, checking to see how we needed to orient our plugs for the central box, and the cockpit doesn't fit because there's so little room between the cockpit and the board. So that is a problem. Didn't plan for that at all, and that's an issue. So I need to go back to the drawing board here. We're gonna have to move some stuff around. All right, guys, actually not that bad at all. We just took the central box, twisted it 90 degrees, and it's gonna work out perfectly, actually. So that's all we really needed to do. And and move the air valve over here. So we just need to take that air valve, slide it over, and that's not a problem at all. So that actually worked out better than I thought. I thought I would have to redesign the entire tray, but no problems with that. So just gone through and plugged in all of our servo leads. We have one more lead to run for the afterburner light. So that's our second throttle channel, which is E314. That comes underneath the board, and that plugs into the RPM port right here on the central data unit or screen or control hub, whatever you want to call it. So we'll get that run. And when we did the move here, the only thing we really needed to do is we had a really short cable going in between the Cortex and the central box, and now we just did a regular cable that comes up. That's about a foot long or so. So wiring is almost done. So we've got our wire leads done up here. The central box ones are very, very simple, so those just come to an MPX connector. And then our turbine / compressor lead, so that's the turbine power. We've spliced into the lead up here, and we've got some wire that's going to feed the compressor, and those lines are going to be soldered to the compressor lines. So we got our battery connectors, plug-ins in place. So we've used 20-minute high sol to glue those in place, and then spot glued them with a little bit of medium CA. So those are all done, ready to go. We will label these, but obviously red is turbine, the single, the double is for your receiver packs. Pretty much have the board all figured out here now. We're gonna put our primary receiver right there. We've got our nice little short lead going into the Cortex. There's gonna be another lead from E2 that's gonna come to this front portion of the board right here. And then we're gonna have R2 coming to the front portion here as well. Those two plugs will go into the clone receiver, which will be right up at the front here. So primary receiver, we're going to run our antenna up and sideways across the plane right in this area. And the other antenna we're going to run over here, and that's going to point forward and backwards. Our clone receivers, we're just going to add a couple more directions on the antennas for that, somewhere in this front area there. So we're just doing up our other leads to get all this stuff done. And once the lead is done in the central box, then we can start fastening these wires together nicely. You can see there our power wires come underneath the board, still very serviceable. And then we have to use our jetty switch, our remote switch, which we'll plug into the switch port, and we'll just stick that on the side of the fuselage. All right, more progress. We've got our wires run forward here for the clone receiver. Those are marked as well, so we know exactly where those are going in the clone. Our primary receiver is in its final resting place, which is awesome. We've got all of our wires here run nicely. They're tightly bound with zip ties and they are very clean. I like that. And last thing to do here is kind of in this section, I'm going to bundle all those wires together and cables and everything and use the clip that I talked about earlier. That's in there. I've just been waiting because we glued the compressor in place. So next thing I'm going to move on to here is the antenna mounting. So we're going to get our little 3D mounts that we have and we'll put one right there. And the other one is going to be in this kind of location right there. All right, so we've got our clone receiver mounted on the front board here. Now the lines aren't plugged in yet because when you're using a clone receiver like this, it needs to be paired to the owner's radio. If we set the clone up on my radio and then transfer the program to the owner's radio, the clone won't transfer over. So we just get this mounted, get everything run, ready to go. Then this can be bound to the owner's radio and then the lines just get plugged in, super simple. We've got our remote on-off switch right there. We still need to run our lead over to the central box. We'll do that here shortly, but we are looking awesome. There's pretty much the install complete. So we've got a clone antenna here. We've got another clone antenna here pointing up and down at an angle. We've got one of our primary antennas here side to side, and then another primary antenna right here forward and backwards. Install is essentially complete with all the electronic bits. So next thing we're going to do to get ready for firing up this engine, because that is what we're doing in this video, is we want to get the sequence on the doors sorted out. So that's going to take a bit of radio programming. So what I'm going to do is we're going to manually open up the gear, drop it down, no air in the system, so then we can time the doors properly and get that stuff sorted before we do anything else. All right, so we've got our plane on its wheels and we've got our flexi spot desk way high up. It's like 44 inches right now, which makes working on this just beautiful. So let's go through what we're doing here to make our door locks work. So initially when we were setting this up, the door locks were set up on the gear switch. So what we need to do is we need to go in and create a logic switch. So we'll go into advanced properties, logical switches, and I've already played with all this, so it's all set up, but we've got our door lock logic switch. So labeled it as door lock, it's enabled. The switch is the gear switch, which is SB, which is right there. So that is our switch. No conditions, and what happens is after 12 seconds, the servo will close only in one direction. So only on the gear up direction. And then when we go gear down, it should be instantaneous. So then what we do is we go into our model, function assignment, and our function, which is door lock function, we want to change this to our logical switch that we just created. So logical switch, door lock, okay. So now the door lock is controlled by the logic switch. So our lock servo is right there. Our gear is in the down position. So let's go gear up. And it should take 12 seconds because that's what we've got it set to before that lock closes, which allows the gear plenty of time to come up. Of course, we can adjust that and boom, 12 seconds later, the lock locks. Now I'm going to activate the switch for gear down and that should open instantaneous. So ready, set, gear down. Perfect. Okay guys, we're going to do a gear cycle here for the first time. So we're lifting the plane off, gear is up. There we go. Doors are closed, listening for the lock. Lock is locked. And gear down, lock comes open right away. and all the gear come down. That is perfect. All right, guys, we've got the aircraft here on its ground, on the ground on its wheels, and she's looking awesome. So we filled the fuel system up. Didn't quite fill it, so I filled the UAT first, and then we filled it right to kind of the half-inch below the vent lines there. The reason I only went that far is I don't have an overflow tank right now. So to get it to this location right there, that was 7.1 liters. We're probably 7.3, 7.4, I think, somewhere in that range, but that is our fuel system. So it's full right now. So before we run this engine, we want to make sure we prime the fuel system. So right now, we are completely dry to the engine itself. The UAT, this is the first time it's been full as well. You never want to take fuel out of your UAT. Now we're going to do a little shameless plug here for the lighter side of RC After Dark. You guys are in a camera time warp right now, and you may be watching After Dark, and then if you watch this video, you're watching yourself in the future? In the past? In the past. Ooh, that's trippy, hey? So the reason you don't want to drain your UAT tank is if you drain it, your little filter or whatever you're using in there is going to be exposed to air. And then next time you fill it up, there's a real good chance you'll have a big air bubble in there. So always leave your UAT full. And that's why I always do a full throttle check before running my aircraft or flying my aircraft. So let's prime this thing and we'll get it ready to run. All right, so we are going to test run the engine. Now, just to give you an idea of what exactly we do during this test run. On the first runs like this, I always will put up on the screen exactly what we're doing, but this is the process for test running this engine, or these engines in general. Now, we've already test run this engine in the shop, but you got to remember that this is a brand new fuel system, new restrictions, new setup, new pump, all that stuff's brand new. So first thing we'll do is we'll start the engine. We will let the engine stabilize at idle. That's very important. If you switch anything in your fuel system, if you put a new ECU in there with Swiwen engines, what I'm telling you right now is what you should be doing. So let the engine idle, stabilize, and then you want to, about over a 20-second period, slowly move your throttle stick to max. Take 10 to 20 seconds to do that and let the max RPM stabilize. So the max RPM on this aircraft is 98,000 RPM. So we'll wait for it to stabilize at 98,000 RPM, and then we're going to come back down on our throttle stick. We'll do some acceleration checks, make sure we're happy. It's very cold outside right now, so we're not going to change the acceleration because it wouldn't be valid when we're flying when it's really warm out during the summer. And then we'll do a restart test and make sure we're happy with that. I got to check and make sure restart is turned on. And that's basically the test run. So I'll put up on the screen while we're going through that stuff, but enjoy. Okay, so we've pretty much idled, we've stabilized, so now we'll slowly go to max. Good? Check our acceleration. Good? Ready? Yeah. One more. Restart check. Okay, get a good hold on it. Ready? All right, so that was awesome. I'm sure Ward had a bit of a struggle holding that plane back. Yes. Lots of power from the Sweetwind engine. So the acceleration was like 4.1, 4.2 seconds, which was crazy fast. The restart was awesome. No issues with it at all. As far as fuel goes, it used, well, you can see the line right there. Yeah, that was pretty awesome. Very, very impressive plane.
There's a lot of fuel still left.
Oh yeah. All right guys, and that is the end of this video for the BVM F-16 1/5 scale aircraft. We have one more video to go. It's a little bit odd doing the engine run up, not in the final video, so make sure you tune into the last one because we're doing all of the final bits and bytes and the scale details and just wrapping everything up on this aircraft. So it's going to be pretty intense in the last video with the details. So thanks guys for watching. Don't forget to check out the lighter side of RC after dark. And we do live streams from the shop here for about 2 hours every 2 weeks-ish. And it's fun interacting with you guys. And you also get to see some of our content weeks before it actually comes out in these videos. Thanks for watching, guys, and we will see you in the next video.